Hello and welcome back. In last two videos, we dealt in department with hFE parameter for NPN transistors. We have learned the difference between beta, hFE with capital FE, and hFE with small fe. We demonstrated how to take hFE measurement using dedicated port on multimeter. We also verified the measurements by manually checking values for collector-emitter voltage, along with base and collector current. If you have not seen these videos, please watch them, as they are prerequisites for fully understanding this video. In today's video we will recreate the exact same scenario, using breadboard, some DuPont wires, resistor, and NPN transistor 2N3904. What we know from before is that, hFE is current gain of the transistor, when transistor is biased for amplification mode of work, with no small signal present at base terminal. Colloquially, hFE is also called beta, or amplification of the transistor, but that is not entirely precise nor correct. From previous videos we know, that for our test NPN transistor 2N3904, when measured by multimeter, hFE parameter equals 194. We also have measured that, collector-emitter voltage is 2.94 volts, base current is 10.1 microamperes, and collector current is 1.81 milliamperes. So, our task is to select appropriate voltage source, biasing resistor RB, recreate this circuit on the breadboard, and to measure base and collector current, so that we could calculate hFE parameter from these measurements. What we need, first, we need 2.94 volts power source. We don't have exactly 2.94 volts power source, but the next best thing we have, is 3 volts output from our refurbished PC power supply unit. Please watch episode 14 of pilot season to see details about this. Now, that power source is dealt with, next thing to do is to calculate value for base current limiting resistor RB. Please note that voltage drop across base emitter junction is between 0.65 volts and 0.8 volts, for silicone transistors. In this, and all other videos, we will use 0.7 volts as value for voltage drop across base emitter junction. Value for base resistor RB is calculated as, difference between voltage across collector emitter junction, and voltage drop across base emitter junction, divided by desired base current IB. For our scenario, values are, collector emitter voltage is 3 volts from power source, voltage drop across base emitter junction is 0.7 volts, and desired base current is 10.1 microamperes. All those values are obtained from previous two videos. This gives us value of 227 kilo ohms for base current limiting resistor. As this specific resistor doesn't exist, we will use next best thing, 230 kilo ohms resistor. So, our final circuit looks like this. Now, our task is to take measurements of power source, base resistor, base and collector current, verify them, and then to calculate value for hFE, using breadboard, some DuPont wires, NPN 23904 transistor and base current limiting resistor RB of 230 kilo ohms. Using multimeter on DC voltage selection, we will insert probes into breadboard, to measure voltage that power source provides. If your probes are of thicker design, and cannot be inserted into breadboard slots, you can measure voltage of power source directly. As expected, our power source provides 3 volts of DC power. When taking measurements for value of the resistor, please take measurement with no power source on, or current running through the circuit. If your circuit is powered on, you will not get correct measurement for the value of the resistor. You take measure by placing each probe in the same slot as resistor terminals. Resistors have no polarity, so it doesn't matter which probe goes on left, or right side of the resistor. Set your multimeter to appropriate range for measuring resistance, and take measurement. Our setting is on 2 megaohms, so the measurement read 0.23 megaohms, which is 230 kiloohms, precisely. Next, we will take measurement for base current, by placing multimeter between base resistor and base terminal of the transistor. We will set our multimeter on DC current settings, in range of 200 microamperes, and take measurement. We take measurement of 10.1 microamperes. Also note, that collector terminal doesn't have to be connected to VCE, in order to take this measurement. We are simply measuring the current coming out of the base resistor, and going into the base terminal. And finally, with our power source on, base resistor in place, we will take measurement of collector current, in order to calculate hFE parameter for this particular circuit. We will use multimeter in DC current setting, in range of 20 milliamperes. We will place red probe on positive rail of power source, and black probe at collector terminal of the transistor. We take measurement of 1.82 milliamperes for collector current. Finally, with all measurements taken, we can calculate hFE parameter for NPN transistor 2N3904, with these particular settings for power source, base resistor, base and collector current. Formula for calculating hFE parameter is ratio between collector and base current. So, if we divide 1.82 milliamperes of measured collector current, with 10.1 microamperes of measured base current, we get value of approximately 179. Remember that hFE parameter has no unit of measurement. Colloquially put, amplification of this transistor is 179 times base current, when using 3 volts power source and 10.1 microamperes of base current, with no small signal present at base terminal, and transistor is biased in amplification mode of work. Please, before you leave, show your appreciation by liking this video, sharing it, leaving a comment, and consider subscribing to the channel. Thank you, and see you next time. Bye.